So in this question, we've got a electron that's being accelerated through a potential difference. So it's being accelerated from the negative to the positive there. So I just labelled that as an E just to represent the electron there. And this bit in blue represents perhaps a positive and negative plate. It says that it's travelling through an electric field. So that electric field is going to cause an upward force on the electron as it's passing through there. Now it's also going to have a downward force, so we can use Fleming's left-hand rule to work out which way the downward force is going to be. So our current finger needs to be pointing in the direction that I've labelled I. Our thumb needs to be pointing downwards, so that gives us our field pointing towards us. So the field coming out of the plane of the screen there, and that provides the downward force. And we need to find the voltage that will accelerate the electron such that those forces will cancel out. So the force of the electric field is little e times big E, and the force from the magnetic field is EVB. So we need to find we need to find the velocity when those forces are the same. So I've equated them there, cancelled out the electron there, the charge on the electron. So the velocity that it needs to be going at for those to cancel out is E over B. E, we are told, is 1,000 volts per meter, and B, we are told, is 1 times 10 to the negative 5 teslas. And putting those numbers in, then we get 10 to the power of 8. So having found that velocity being 10 to the power of 8, we need to know what voltage will cause the electron to accelerate to such a speed. Now we can do that by finding out the work done on a charge is the voltage times the charge, and we're going to equate that to kinetic energy to find that voltage, because we're told the mass of the electron in our question here. So if we equate those two, then we get half mv squared equals the voltage times the charge. So we've got half times by the mass of the electron, which is approximately 10 to the negative 30, and the velocity we found a moment ago was 10 to the 8 meters per second. So we'll take that velocity, square it, and what we're doing here, we're taking the charge there. So charge on the electron is 6 times 10 to the negative 19 coulombs, and we're trying to look for V, that voltage. So having done all that, then a lot of this you can do in your head. So for example, this section here, you can just use the laws of indexes there. So that's how I've arrived at 10 to the negative 14 there. I've brought the half, so I've divided both sides by half to cancel that out, to give 32 times 10 to the negative 19 times our voltage there. And now we're just going to solve it for the voltage. So our voltage that we need to get our electron to a velocity of 10 to the 8, such that it will cancel out those two competing forces, is 1 over 32 times 10 to the negative 5 volts.